Hello, good morning, and thanks for this opportunity to present my recent work. My research is about language, it's about linguistics, but with technologies, how to use technologies to improve the linguistic resources and natural language processing in general. And this is the topic of the research group, okay? Technoletra, because technologies of language, terminology and translation. In this group, the things we want to do is use these technologies and adapt the technologies that are being used in the computer science, and to move these new technologies to the area of linguistics, to create linguistic resources and using them in research and also in professional applications. Well, along the years, we have seen that there is a lot of limitations in the linguistic resources. And we are going to see some resources that have a semasiological approach or an onomasiological approach, or based on collocations. And based on this, I don't know, the past, how the resources are in that moment, we can see the problems that the resources have, and we have developed a new model that is based on ontologies, based on knowledge engineering, and it's a different model that is based on logic. It's not an arbitrary model, or it's not a standard. It's the way we think that language works based on logic. This is the idea of a semasiological approach, is that the resources present a limb, a word, and after the word, we have the information about what's the domain or the topic, what's the meaning, the definition, what's the part of speech of this word. And this is the approach. We have the word, and we have a lot of information about this word. This is a typical resource dictionary. This is a semasiological approach. And usually, for this kind of resource are created by editors of XML, and also by with databases, terminological databases, for instance. For instance, in this case, we have a list of words, and we have the information about one word or the equivalencies of this word. Obviously, with the terminological database, is more flexible the research, the search of the words, the lookup. But the system is the same, is this semasiological approach. In the onomasiological approach, it's different because we start with the concept, and we can ask for a concept, and then the system give us another meaning, or another word that is with the same meaning. The onomasiological approach is based on the concepts and how the concepts are organized, and how the meanings are organized, and then you start with the concept and arrive to the word. It's the contrary of the semasiological. And another is collocations. We have also resources based on collocations. This kind of resource give us words that usually are in company, are together in a sentence, for instance. Then, for instance, we have words that whose meaning is the same. For instance, in Spanish, obstruir, obstaculizar, taponar, they have the same meaning, but they occur with one word, but not with others. Then when for instance, a translator, a professional of language must use the language in a production process, this kind of resource is more useful, conomasiological or collocations, and semasiological is for other kind, is for comprehension of the text. In this case, we can, in Spanish, we can say obstruir la justicia, obstruir un desagüe, obstaculizar la justicia, but not obstaculizar un desagüe. And we can use taponar un desagüe, but not taponar la justicia. They means the same, but they are different. So we have dictionaries like this is a view of the Redes dictionary in Spanish that works with this type of resource. Well, we have these different resources for build this kind of resources. We need different principles and methodologies. We need different tools also, and based on this, we can get different resources, but usually they are useful for humans, but not always for computers. Well, then our objective was to elaborate some kind of resource that can do this different kind of approaches, semasiological and nomasiological collocations. And the resource were useful for humans and also for computers. Then for that purpose, the databases were very simple. So we start to use editors of ontologies. In our case, Protege is the more used tool for this purpose. This tool is based on description logic, is the ontology web language, OL. And the basic principles behind that is the set theory. Then that means that we have in this, we have not registers and or files and columns. We have classes, properties are individuals. And the question was how organize language in this kind of elements, how they can fit. And there are some models yet that have used ontology editors or have used XML or OL, but they really don't use the logic behind this program or behind this language. They only use the properties of you can join two elements, you can join two, but they are not based in logic. Then our purpose was use the tool using logic. For instance, to describe concepts, we used this was the first part of the work. We use how decomposed the meaning of a concept, in this case black core, because corazón negro is because we work at the beginning in ceramic sector, and then we decomposed the meaning for instance, in property and a value. We have the object, black core, is a kind of defect, and we have the properties here connected with values. Then these kind of properties were reduced in a lot in the definitions of different defects. We always have the same template. Then in this case it was easy because because that's the way that usually are used the editors of ontology. They are used to describe concepts. That's the same or very, very similar in language and in other applications. The challenge was how to implement words, because the problem is that in this kind of approach, in knowledge engineering, they make a similar equivalence between concept and word, but concept and words are not the same. And we can see that in the approaches semasiological, onomasiological, or collocations are different things, concepts, words, and connections. Then, for instance, we can represent black core as a concept, as a class in an ontology. That's no problem. But the thing is how to implement the rest of the information in linguistics. So we study knowledge representation. We saw that the subject of the ontology is the study of the categories of things that exist or can exist in this domain. And the product is an ontology, and it's a catalog of the types of things that are assumed to exist in a domain, etc. But that's in general, for instance, in ceramic sector. But it's the same in linguistics. It's the same when we work with language. No? The thing is that this in a linguistic approach, the domain is not, for instance, the ceramic tiles, or not. It's not the cars. Or it's not the real world, the real things in the world. For us, the real things are the words, and that was the change and change of perspective. So then the words will be represented in our model as individuals, because they are the content of the conceptual of the knowledge database. And things are, for instance, words as mountain or the house, but also, for instance, for us, suffix or prefix or prepositions or this kind of every kind of word. The categories of things for us in linguistics are, for instance, term, for instance, word, for instance, morpheme, for instance, verb or sentence. That's our linguistic concepts in this case. So terms will be represented in our model. Ontodic model is the name, as individuals. Linguistic concepts will be represented as classes, and will be linguistic relationships between classes or between individuals, or between concepts, linguistic concepts, or between terms or words, etc. This is the idea in general with classes, what will be represented as classes or as individuals or as object properties. In Protégé, this is a view of Protégé, is the panel of classes and the class hierarchy, in which we have part of speech with subclasses like noun or verb, grammatical gender with subclasses as masculine, feminine, general grammatical number like singular, plural. Natural language will be another class with subclasses Italian, French, English, Spanish, and this is a representation in the panel. The thing is that knowledge engineering has a T-box and E-box. This is the terminological component, and this is the assertional component. Usually in these cases is the mess in other applications that mess the classes with real words, but for us is word is a class, and the individual will be, for instance, untouchable. And then we have the relation untouchable has a relation has-based touch, because it's a typical relation in linguistics. The same in the level of the T-box, we have word, has-base, lex-base will be the way to call. This is an example. Then we will have different levels, because in language we have different levels. We have the morphological level, we have the grammatical level, the lexical level, the semantic level, and others. Then in each in every level we have different relationships, and we have relationships that are in the T-box and in the A-box, relating the classes or relating the individuals. And we have these different levels. That's important because that means that we will have different hierarchies. And the thing is that the real words, the words that we have in a dictionary, for instance, like untouchable, will be connected with a lot of classes or subclasses in the hierarchy. Then we will get a multidimensional system in which the logic works, because logic work on the classes and subclasses, and the individuals only receive the information, but they don't have to execute any reason. Well, this is a view of the model, which we can see, for instance, in this part, the individuals. The individuals, like horno, for instance, is the word in Spanish, or kiln is the word in English for the same concept. Then the two words are connected with the concept horno, because it's the semantic concept horno that will have associated the information about definition that is not shown here. But this concept is connected with machinery, that is connected as a subclass of the ceramic domain. This is the part of the semantic level, we can see. Semantic or conceptual level, and where we have classes and subclasses. And kiln or horno are instances, because they are individuals, are connected as instances of these concepts, classes. And in the other side, we have that they are terms. The terms are, in fact, subclasses of a linguistic expression and subclass of a meaning, a concept. Then that's the nature of the words, is that they are connected with the linguistic system and with the conceptual system. Then we have again, these individuals, these words are connected as instances of linguistic concepts like noun. They are nouns. They are simple form from the point of view of morphology, or they are, in this case, Spanish, or in this case, depend, or is an instance of the language English. And also these systems allow us to have deductions on inference. For instance, we can inference because the orno y kil, they have a relation of equivalence. They are equivalent, and this is, we can assert this information, or we can also implement a rule because they are individuals that are connected with the same meaning, and this is the meaning of equivalence. They are equivalence words. It's because they pertain to different language, but are connected with the same concept. So this is after a lot of proofs and studies, we have deduced this model, and it's a model that is based in logic, and we think that can be very useful to use in natural language processing and produce dictionaries. This is an implementation from the ceramic sector. For instance, we have here the classes. Orno as a concept is a subclass of instrumento. And in this part, we can see the explanation, the definition, the description of the concept. And we have here, we cannot see that. One instance of this concept, of course, will be orno. Here we can see the view of the individuals, and we have the list of individuals, the list of words in the resource. We have marked here orno. Then we have the description of orno with all the classes to which is connected, and also because orno is the concept. Here we have the different words that are connected with orno, with this orno. So they are the different words that are used for this concept in different languages. Well, we can have a very similar view here. But we have here, we have marked sustantivo is noun. Then we have here the list of words that are instances of noun. We have, especially in Spanish. Or here the view of terms that are friends in Francés, and we have the list of words in French, what we have in our resource. And the class noun. Then the thing is that with this, we can get a view, a visualization of the connections of the elements and connections that we have in the system. This is a small part. And this in some way give us the intuition that there is some similarities with, for instance, neural networks in artificial intelligence, or maybe can be connections with neural networks in biology. We would like to explore these possibilities, but we are not experts in these parts. Well, the conclusion is that ontologies are a very flexible tool for work with any domain, including linguistics. That ontological modeling enables integration of different perspectives and representations of language. Ontological modeling requires the study of language from the perspective of logic and mathematical set theory. And knowledge-based methodology and tools using our model in ontology can help the terminologists work and improve the final product for users. The idea is work together with people also in artificial intelligence because and natural language processing, and analyze and specify the logical relations that exist in natural language resource in this way. Develop a software application for lexicographers based on this model because it's a bit difficult for them to get familiar with a tool like Protégé. It's a bit difficult. And also analyze similarities between networks of linguistic relations with neural networks in language models or in neurocognition. And this is my presentation. Maybe if you have any doubts about anything, it will be a pleasure to receive any feedback from you.
Yeah, I would like to ask a couple of questions. Can you hear me?
I cannot hear
Yes.
very well.
Can you hear
A
me?
moment, I cannot hear.
You cannot hear. God. Let me do it differently. Can I ask? I would like to ask a couple of questions. So one thing is, so you have a lot. Hello, can you hear me?
No se oye. Yes.
¿Me puede oír? ¿Me puede oír?
Puedes escribir.
Not very much. Maybe you can type your question. Maybe you can say it.
Yeah, so my
If you can type your question, maybe it will be better.
Can you hear me now? Sorry, I can't. It's very difficult. Not very well, but I will speak louder now.
Now we can hear you.
Yeah, my first question is, so you have a logical model based on ontologies. I mean, it's well known also that ontologies can be translated into first order logic. So could your model be put together to other existing models of language that and enrich them, such as Montague grammar, which is a model based on quantification, proper treatment of quantification, etc. So that's my first question. Okay.
I hear you very bad. I can imagine your question a bit. I think I hear something about to join this model with other ontologies.
Not ontologies, but with other logical models of language, like Montague grammar and other things that are logic, because what you are doing is logic, okay? So why wouldn't you be able to join, why wouldn't you be able to put this together with other logical models and make a richer model?
That's the idea. The idea is work with other people that works in natural language processing and with other systems, and to see how to fit these resources with other systems, because I think the ontologies now have some problems of interoperability, and
Yes.
my intuition is that a lot of these problems are because they don't understand very well how works linguistics, because linguistics is the linguistic sign has two parts, that is the conceptual part, and the linguistic system part is the semiotic sign also, and when you don't take into account this the system, the linguistic systems, other equivalencies between concepts, I think they don't work.
Yeah.
I can see you.
Thank
now.
you. So my second question is about large language models, and my third question too. So what is the interaction? Second question, can you help large language models? So your ontologies, can they be used to train and fine-tune large language models so that they get better, maybe even better in reasoning? Because all these relationships, some of these relationships will be known to large language models, but other the relationships will not be known. So, for instance, a large language model already knows what kind of ornos or of ovens there exist. So we don't need to explain that, but maybe some other stuff that you do could be used to train and to teach and fine-tune large language models. So what's your idea about that?
Yes, I think so. I think I have the same this intuition, that intuition that we can use these resources to train language models and to train other systems in artificial intelligence. That's my illusion also. I will like a lot that. But I'm not an expert in this part. That's a problem. I have studied, but I'm not an expert in this part.
Yes.
So I need also that you or any team say me, we will have this amount of resources built, and we can work with this amount of resources, or what do you need? I don't know, but the model is finished. Then the thing is, what's the next step to do now?
Yeah, I think that's very interesting. And my last observation is just an observation that you could also, on the other hand, you could use large language models to improve your model and to add many new relationships and concepts, etc., from large language models. As I said, if you ask a large language model, what type of ovens, of ornos are there? Yeah, they know it. So you could, and sometimes they know you can make sure that this answer is. You can ask the system about how sure it is, and sometimes it is very sure about these answers. And then you could enter these answers into your ontology, and you could get a bigger ontology from large language models. Okay, so I think there could be a very fruitful interaction, bilateral, how to say, from both sides, interaction, between large language models. And I think that would be the next logical step for your research, to find some young researcher who is an expert and who can put he or her hands on large language models, and to experiment a little bit on how you can interact with this, and whether you can either train it or obtain additional data from it. Because large language models are the optimal way currently of doing linguistics. Yeah, so it's so much better than so many other approaches that have failed. Yeah, all the Chomsky stuff is very interesting. The Montague stuff is very interesting, but it did never lead to a usable system. And the only approach that led to a usable system is the statistical approach underlying large language models. But it's very possible that this statistical approach can be improved or can be used to improve a logical approach.
That's all I wanted. I'm not sure if I heard all, but I agree with you, and I want to explore all these things. Yeah, thank you.
That would be great.
Sociology,
Mhm.
which is about the relation between the significante and significado.
Sí.
So between the signifier and in English should be the signifier and the signifier, maybe.
Yes, it depends on the author, but the first one was Saussure, and that's this words.
So this goes a little bit on your study, no? This type of ontology or ontological approaches, they are very interesting to provide additional semantics or more deeper semantics to large language models, but there is always a problem here. And from point of view of sociology, is that we need a world model. Not only a language model, but a model of the world. Otherwise, how can you relate the significante and significado if you don't have a model of the world? I mean, this is the
A model of the world.
Yes, model of the knowing.
Yeah.
This is the object of the world, the properties of objects. You say
Yeah.
that the sun is warm.
One part is this. Yeah.
Main difficulty in dealing with language in AI.
Mm-hmm.
That there is a lack of knowledge of the world.
Yeah. Well, this part is about concepts,
Yes,
the semantics.
if you really want to have a future AI, future language system that understand the notational semantics. The notational semantics, not only the distributional semantics or latent semantics, but the notational semantics is the one that needs.
Well, in this in this model, I don't know if you will mean something like that. In this model, we have another part. No, it's, well, will be like another level that is objects, because in this part of we have words as individuals, but in this part we can also have objects. The idea is that we can have objects. We have here linguistic expression, meaning, and other big concept will be things like objects in the world. I have not, but for instance, in this case, horno or kiln, we have some references of hornos in the industry. That's objects. That's reference. Right? The reference to it, and the other is the meaning in the way we decompose here. That is similar that in knowledge engineering. The thing is to do that with other domains, not only ceramics, but also in other domains. But of course, I think it's important to do that.
What means fighting?
That's no. The idea is that it doesn't. Yeah, but the thing is that the important things here is not the words, of course. It's the relations.
Concept, yeah.
These relations. Yeah. Yes. This relation, and for me, the next step. Yeah. The next step is how the logic of that. For instance, if it's transitive is symmetric, this kind of properties in logical, and also organize these relations in some way. Because if they are explained from the point of view of logic, the system can think with that. But of course, that's another challenge, is how to connect with the physical world, of course. Of course. And that's the problem. A lot of systems of this, because they are working with words, only with language models. They work with words, but they don't know that there's a real world behind that or connected with that. I agree with you.
Descriptive logic, it's also a language that, doesn't know.
Yeah.
It's very hard problems.
Yeah. But we are in that. Yes, of course.